We're now going to take a look at truck and tractor air brake system components. So we're going to take a look at each of the components in the system and how they work and then how they work together. So this is a two-part video. So first, if we take a look at a schematic of how an air brake system is set up. Now they do vary between manufacturers, but this is a generic truck and tractor. So again, because we have the tractor protection valve, it goes to the trailer. But we're going to start with the very basics. We're going to start out with the beginning of the air system. So the air system, the very basics of it, consists with our air compressor, our air dryer, and our supply tank. Supply tank is also called a wet tank. So from the compressor, it compresses the air, goes through the air dryer, and then into our supply tank. So let's take a look at the air compressor first. So the air compressor, again, depends on whether it's how much air we need for the vehicle. So we can have a 4-cylinder air compressor or a 2-cylinder air compressor, but the basic function of the air compressor is still the same. The air compressor is just like a little engine. Okay, so it has a crankshaft. Now, most of the new air compressors now are directly driven off the engine, so they're gear drives, where the older ones on the older trucks were a belt drive. And some of the issues we had with those ones were, as the pressure got up to whatever it was the governor was set at, the amount of energy required would cause the belt to slip. So now all the new ones are belt or gear driven. So inside the compressor itself, we're going to have, for instance, on a 2-cylinder, we'll have 2 pistons, we'll have connecting rods, we'll have a head. Now, most of these, the heads are liquid cooled, so we'll have an inlet and outlet for coolant from the engine to be forced through to keep that head cool, because again, as we're compressing air, we're generating heat. We have to dissipate that heat, so we're going to use coolant. Now, the block of the compressor is also cooled by air as it's flowing around it, so that'll help keep it cool. So taking a look at inside the compressor, so again, as the piston goes from top dead center down to bottom dead center, it creates a vacuum. We have a discharge valve and an inlet valve, and these valves are just a little plate with a spring behind them. So what happens when the piston goes from top dead center to bottom dead center? It creates negative pressure. And what happens is on the discharge port, there is pressure there, and it closes the discharge valve. What happens then with the negative pressure is our inlet valve will open and allow air to come in to fill the negative pressure. Now, depending on the type of vehicle we have, on the older style they used to have an intake strainer or a filter on the outside. The new ones now are fed off of the intake manifold, so we're actually pressurizing the system through a turbo, but it's filtered air. We don't have to have an external filter on it. So then what happens is when we go from bottom dead center and the piston starts to move up, no more negative pressure, the inlet valve will close. Now, as soon as the pressure starts to build and it exceeds what's on the other side of the discharge valve, that will open and pressure then will push out through to the reservoir. And in most cases now it's the air dryer, but it pushes out of the head of the compressor. And this just continues until such time as our governor signals our compressor to unload. When it unloads, what happens is both intake valves open. So air pressure comes in from our governor, and we'll talk about how the governor does that a little bit later, or next slides. And then what it does is it pushes up and it holds the intake valves open. And what happens then is on a 2-cylinder, when one piston's at bottom dead center, the other piston's at top dead center. And all it does is just cycles the air between those two cylinders back and forth. Because we can't build pressure, the discharge valves can't open, and the compressor goes into what's called an unload state. Let's just say that once the pressure in the reservoir gets to 120 psi, the governor sends a signal to the compressor to unload. Now, the way the governor's set up is it's 20 psi difference. So once that pressure in the reservoir drops below 100 psi, the governor will cut back in. This piston will drop, and the compressor will start to charge again. Once it gets to 120 psi, we get a signal from the governor. It's going to tell the compressor to unload, and it goes into the unload state again. And this just keeps going back and forth as air is used up in the system. So taking a look at our governor and how our governor works. So our governor is usually, in most cases, bolted right to the air compressor head, but it can be remotely mounted. And inside we have all these components. So as pressure starts to build in the system, what happens internally? Well, if we take a look at our governor itself, air pressure from our reservoir, again, remember, as pressure is being built up by our compressor, it sends it to the supply tank. So it's also called the wet tank. So we take our signal line off of there, and our signal line comes in the bottom of the governor, and it pushes up against this red piston. It also pushes up against this inlet seat. Now, when the pressure starts to build and starts to push up, it's pushing against spring pressure. So the spring is up here. Now, the other components we have in here is we have an exhaust stem, we have an inlet seat, and an exhaust seat. Now, these are both the same. So a lot of the stuff that we're going to see in air brakes, they all function the same way, is our inlet seat and our exhaust seat will both be the same component. We also have a port from our unloader that is vented out through our exhaust port on our governor. Now, as the governor pressure starts to build, so pressure again starts to build, starts to force this up as a unit, this whole unit, this red component, is going to move up against spring pressure. So what happens is, as it starts to rise, this component will move up, and what's going to happen is it's going to unseat our intake valve. But again, first thing that always happens is our exhaust port's going to close. So this is our exhaust port here, so it closes. Next thing it does is opens our inlet seat and allows pressure from our wet tank to get around the inlet seat. It can't go out the exhaust, so it has to go out to the unloader. Now, from the unloader, it can go to two components. It can go to the air dryer to tell the air dryer to purge, and it can go to the compressor to tell the compressor to unload. We're at our maximum we want on our pressure. We don't want to build any more after that, and that's what the governor controls. Now, what happens as air pressure starts to drop, as we start to apply brakes? Our wet tank pressure starts to go down. What happens then is spring pressure is going to overcome air pressure, and this red component is going to start to move down. As it starts to move down, the inlet seat is going to seal off any air, and then the exhaust port is going to open. And when the exhaust port opens, air that's in the unloader is going to be lost out to atmosphere, and our compressor is going to cut back in. Now, the other problem we have is moisture in the system. So a couple of things that we might see in a system is an automatic drain valve, and these will be located on the wet tank. And what happens is every time the compressor cycles, it's going to allow a little bit of the air to purge out the bottom, and this will get rid of any moisture. The one problem they had with these is, especially in cold temperatures, is they'd freeze up and they weren't very good. And again, we don't want moisture going through our system, so what we do in a lot of the systems now is we have an air dryer, and we'll go through that next. But how these automatic drain valves work is really quite simple. So air pressure comes in and is forced down on top of this valve. It forces the exhaust closed. Now what happens is, as pressure starts to build, it forces any moisture that's in that air out around the outside of this. Now again, because pressure is greater up above than it is down below, it will open up around this circle and allow all of this to go in till the pressure is equalized. Now any moisture that's in the tank will be forced down through this and sit in this bottom area here. Now once pressure is equalized above and below, this will close off and seal this moisture in. Now we have equal pressure above and below this piston. Now as we start to use up air pressure, what happens? Well, the pressure up above is going to be less than it is down below, and that will force the piston up by air pressure, and any moisture that's in here will be exhausted out. And it will stay in this position. Now again, what happens is, as the compressor cuts back in, our reservoir starts to fill up. It's just going to repeat. Now, before air dryers came out, they used to use alcohol evaporators, and that was to help prevent any ice from forming in our system. You may still see it on some vehicles. You may see an alcohol evaporator, and what it does is on the compressor discharge, it will draw in, or on the intake, it'll draw in a little bit of this alcohol to prevent freezing up of any moisture. All air contains moisture, depending on the atmospheric temperature and pressure. So there might be a day that we have more moisture in the air than we do on a dry day. So we've got to get rid of that moisture before it can go through the system. So what we use now is we use an air dryer. So an air dryer has a desiccant in it, and the desiccant will absorb moisture as it's being pushed through. So air comes in from the compressor. So we'll go through how this system works. So air comes in from the compressor, goes past our delivery valve and up through a filter in our desiccant, and then through the desiccant itself. From there, it goes out through a one-way check at the very top of the cartridge, and then down through a one-way check valve out to our wet tank. Now this does this all the time as the compressor is compressing air. So what happens when the compressor goes into the unload state? So what we do is we get a signal from the air dryer, or from the air compressor governor. Okay, so it unloads, and what it does is it pushes down our purge valve. When it pushes down the purge valve, it shuts off our intake because, again, our compressor isn't compressing anymore, so it shuts that off and opens up our exhaust port. And what happens internally inside our air dryer is the air that's in here under pressure gets forced out the exhaust port. And what happens then is, as air is rushing out, it strips the moisture off the desiccant particles, and that moisture gets ejected out the exhaust port. Now, the other thing you're going to see is at the very top there's an orifice, and the purpose of this orifice is to help this air escape faster. You've all taken a water bottle and tipped it upside down and poked a hole in it, and what happens is that water now will run out faster because air can get in there faster. It's like shotgunning a beer. So we need to make sure that that hole is never plugged, because it helps to, as that air is rushing out, it helps to strip that moisture off the desiccant cartridge tablet or pellets. Now, when that pressure inside here drops, this one-way check is going to close, and so the line pressure from our discharge to our wet tank remains at whatever our wet tank pressure is. Let's just say 120 psi. So a couple things that we can look at when this is happening. So if air constantly comes out of our purge valve, it could be because this one-way check is leaking. And what's going to happen then is our wet tank pressure is going to slowly drop down. Our compressor is going to cut back in, and this is going to keep cycling. So if our compressor keeps cycling, for instance, say every 30 seconds, it could be, and our purge valve is leaking, it could be because this one-way check at the bottom of the air dryer is leaking. So off of this line that goes out to our wet tank, now our reservoirs can be set up so that our wet tank and our primary and secondary can be together. So it all depends on the manufacturer. But what we have between them is a one-way check valve. And taking a look at how the system's set up. So off of our supply tank, it feeds the primary and the secondary, and we have one-way checks on each of them to protect the system if we have a failure. So let's just say we rupture our supply tank. The one-way check on each of the primary and the secondary protect the primary and secondary tanks from losing air. Very simply, how does a one-way check work? Well, as air pressure builds and it exceeds the pressure on the other side, it will lift off its seat and allow air pressure to build. Once pressure on this one side drops below this pressure, the spring pressure will push this back on its seat and protect any air on the other side of it. In order to protect the system from overpressuring, we are going to have safety valves set up in the system. In most systems, we're going to have 3 safety valves. There will be one on the compressor in case the discharge line freezes up or breaks, or freezes up or blocks off. We're going to have one on the air dryer, and again, the air dryer has a heater on it, so if that fails and it freezes up, it protects that system. And we're going to have one on the wet tank or the supply tank. We don't need one on the primary and secondary because they can never exceed what the supply tank pressure is. Most of our pressure relief valves are set for 150 psi, and our cutout on our governor is should never exceed 135. And how they work is pressure from the reservoir acts on the surface area on a ball. Once it exceeds spring pressure, the ball will lift off its seat, and any extra air pressure above that 150 will be exhausted. As soon as that pressure drops below 150, again, spring pressure will overcome air pressure and it'll reseat itself. On some of them you may have a clip that we can test them to make sure they work. Inside the cab we're going to have air pressure gauges. Now, depending again on the manufacturer, we may have a single air pressure gauge that has a red and a green indicator. So one might be red and one might be green, and that's primary and secondary. Primary is green, secondary is red. And again, we may have separate gauges in the cab for primary and secondary. The other thing we will have is a low air pressure warning buzzer. And again, it's just a contact switch. So once the pressure drops below a certain point, again, whatever the spring pressure is set at, the contacts will make contact and the buzzer will go off and a light will go off. So as soon as that air pressure exceeds that, it'll break the contact and the light's going to go out. So when we start up the vehicle at the beginning of the shift, if our air pressure is low, the buzzer will be on until the pressure comes up to a certain point to break the contact. Another thing that we're going to take a look at is relay valves. Now, relay valves come in many varieties of, again, what do we want them to do. And a relay valve is like an electrical relay. What we're using is a small amount of air to control a large amount of air. We don't want to have all this air going from the front of the truck all the way to the back of the truck through a large line to make an application. So what we're going to do is off our foot pedal, we're going to use a small line, and it's going to enter through this port here, and it will allow system air. So this will be hooked up through a larger line to allow air pressure to go out to our brake chambers. The lines that we use, most of the lines now are nylon tube or Synflex, and again, we're going to use brass fittings. Now, one of the things we should be doing is anytime we're setting one of these up is making sure we use the insert, and that insert fits inside the tubing so it doesn't, so the sleeve when it gets compressed doesn't get distorted. These fittings, because of the way that they're set up, we don't have to tighten these up really tight or we run the risk of splitting the fitting. Steel tubing, we still see some steel tubing around, but not as much as we used to. And again, the sleeve, when we put it inside the fitting and tighten it out up, it compresses the sleeve against the tube to create the seal. Air brake hoses, again, they're a special fitting that they have that they screw into the air brake, and then these two connectors fit together, making sure we get the right length of air brake hose so it's not too long and not too short. The Teflon steel braided hoses we usually use from the air compressor down to the air dryer. And the reason for that is the Teflon tubing may have perforations in it, and again, we want to cool that air as it leaves the compressor as quickly as possible, and so this stainless tube will absorb that heat and help dissipate that heat from the air going down to the air dryer before it gets to the supply tank. So taking a look at again how the reservoir is set up, our primary system. So we're going to look at primary and secondary. So we've looked at the compressor, the air dryer to the supply tank, and again through our one-way check it goes into our primary system. And we're going to take a look at our secondary system next. So off our primary system, our air goes up to our treadle valve. It also goes to our spring brake valve, and through another line it goes out to a relay valve. Now the solid green is supply pressure. The dotted line is application pressure. So when I make a brake application through our primary system, so again, primary is always at the top of any of the valves that we have. So when I make a brake application, it's going to go up to a double check valve. And again, double check valve is set up so that whichever has the highest pressure is going to shuttle the check valve over. It also, when we send a signal down to the relay valve, it's going to tell the relay valve to open so that we can make a brake application. Now if we take a look at a treadle valve, they can be mounted either firewall mount or they can be floor mounted. So they both work the same way. So our primary system is the lower one, or this one here, or this one here. Our secondary is the upper one here or here. And how does a treadle valve work? Well, again, when we step on the brake, we mechanically actuate a piston. This piston is going to push down. The first thing it does is closes off the exhaust before it opens up the intake. So air pressure coming in here can't get past this inlet valve, and our exhaust valve, which is here, is open to the atmosphere. So any air pressure that's out in the brake chambers can be vented out through the exhaust. No air pressure can get in past the inlet valve, so no application is made. So when I step on the actuating plunger, it pushes down, and first thing it's going to do is seal off the exhaust. Then any further application is going to open up the intake. So when that happens, air pressure can get in past the intake seat. It can't go out the exhaust because the exhaust is closed, but then it can go out to our service chamber. Now, a couple of things to remember anytime we are troubleshooting. So one of the big things is, let's just go back 2 slides and take a look. So here our intake seat's closed and our exhaust is open. So if we have air coming out the bottom of the foot valve when we're not making an application, it has to be the intake seat that is leaking. On the other hand, if I'm making an application and I have air leaking out my exhaust, my inlet's open but my exhaust is closed, it has to be the exhaust seat. So we, according to the 121 system, we have to have redundancy in case we have a failure. Let's, for instance, say that our line on our primary is broken. Well, we have a secondary system, and our secondary system is our backup so that we can still make a brake application. So if our primary is leaking, we're going to lose air out of our primary system. That is the primary tank. And it's going to drop down below a certain pressure, and our low pressure warning device is going to tell us that our air pressure is low on our primary system, but we may still have full air pressure on our secondary system. So our secondary system is going to apply our brakes, and we're going to go through on how that happens. But in a normal brake application, when I step on the foot pedal, exhaust closes, inlet opens, and allows air to go out to our primary system. Now, primary systems are our drive axle brakes. Secondary system is our steer axle brakes. So when I make my first part of the application, it's going to send pressure out to my drive axle brakes. Now through this orifice, air pressure is going to come down and start to make the application on the secondary system. Now, same as hydraulic brakes, if you remember from the master cylinder, we used hydraulic pressure to open up the secondary system. This does the same thing. So down here we have another set of valves. We have an exhaust valve and an inlet valve. And what's going to happen again, as soon as air pressure starts to build, it closes off the exhaust and then opens up the intake and allows pressure from our secondary reservoir to go out to the front steer axle brakes. Taking a closer look at how the valves are set up, again we have our exhaust valve there, our inlet valve here. On our secondary system we have our exhaust valve here and our inlet valve here, and we can see that both of these are open. And we also have air pressure coming through our orifice to move the secondary system to close the exhaust and open up the inlet. Now, every valve will have what's called a balanced position. So what happens here is reservoir pressure is coming in and we're making a brake application. Once this pressure on the outlet side equals spring pressure, the inlet valves will close, both of them, and no more pressure can get through to make any more brake application. So let's just say I want to make a 20-pound or a 30-pound brake application. Once the pressure downstream gets to 30 psi, the spring pressure and air pressure equalize, and both inlet valves will close. Now what happens if I want to make a larger brake application? Well, I'm going to step down on the actuator plunger a little bit more. I'm going to overcome the spring pressure and the air pressure, and these valves will open and supply more air out to my primary and my secondary systems. Now what about when we go into the release position? When I lift up on my actuator plunger, what happens then? Well, the intake valve is going to close first on both primary and secondary. Then the exhaust valve is going to open. Any air that's trapped in here can now get out the exhaust and vent out to atmosphere. My intake valve is closed on both primary and secondary, and my exhaust valves are both open and allows air to get out through the exhaust, and it will vent through the bottom of the treadle valve. When we take a look at a relay valve, and again a relay valve's function is to use a small amount of air to control a large amount of air. And our relay valve is set up so that we have a piston, and we're going to supply air to the top of the piston. And inside we have our exhaust and intake valve. And again, our exhaust and our intake valve are both the same, use the same seating surface. The outside area is our intake, the inside area is our exhaust. And then we have a spring that will help balance a relay valve. So internally, when we take a look at a relay valve, air pressure comes in the top and acts on the surface area of a piston. Now in a normal state, when we're not making an application, our exhaust valve is open, so air that's in any of the brake chambers can escape out to the atmosphere. And it stays this way, and if you take a look, our intake valve is closed. So primary air comes in, can't go anywhere because our intake valve is closed. So once we make a brake application, it's going to push down on the piston, and this piston is going to go down and it's going to close off our exhaust port. Once the exhaust port is closed, it will push this piston down further, which is going to open up the intake, and it will allow air pressure to go out to our delivery port. So this is in the release position. Intake is closed, exhaust is open. Now, when we go in and we have control pressure coming up on top of the piston again, the exhaust is closed the inlet's open. Now we can also go into a balanced position in these valves where both the exhaust and the inlets are closed. So once air pressure on the delivery side equals air pressure on the control port, this is going to move up and it's going to close off our intake. But it's not enough to allow our exhaust to open, so it can maintain whatever pressure we are putting into the control port. Now, when I exhaust air out of the control port, spring pressure is going to move the piston up. If the exhaust if the inlet port was open, it's going to close first, and then our exhaust port will open. Anything out the delivery port will then be exhausted out the bottom of our relay valve. All relay valves work this way. They may vary a little different in how they look, but a relay valve, the basic function of a relay valve is all the same. Now, when we take a look at a brake chamber, a single brake chamber, for instance, has a diaphragm and a small spring inside of it. We have our push rod assembly and our clevis that's hooked to our slack adjuster. When we supply air in behind the diaphragm, it pushes the diaphragm out, which pushes the push rod out, which will rotate the slack adjuster. Now, our secondary system, again, a primary system runs our drive axle brakes. Secondary system runs our steer axle brakes. So, off of our secondary system, we have a double check valve. And again, double check valves allow for what's called blended air. Whichever has the highest air pressure will shuttle it over. So if primary has the highest air pressure, it will allow air to go back to this valve. If secondary does, it will allow air pressure to go back here. So secondary air pressure comes up and goes to the bottom of the treadle valve, the secondary part of it. When we make a brake application, again, it goes out to our steer axle brakes. It also goes up to this double check valve and this double check valve for the tractor protection valve, and we'll discuss these later. Now, we also get air that goes up to our part valve. And again, if you take a look at the previous picture, we also get primary air up here. Inside this valve, we get blended air so that we can release our brakes. So another thing we have, and it's one of the simplest valves we have in our air system, is called a quick release valve. And we'll see a quick release valve in two places. One of the most common is on a steer axle. When we make a brake application, we want to apply the brakes, but when we release them, we want the brakes to release as quickly as we possibly can, and that's why we use a quick release valve. So in a normal state, there's no air pressure coming in the inlet port. The delivery ports are both open to atmospheric air. There's no air pressure. And this is our exhaust seat right here. As soon as I make a brake application, air pressure comes in our inlet port, pushes down on this diaphragm, which then seals off our exhaust port. Air pressure can then get past our diaphragm and out to our delivery ports to our front brake chambers. And we're making a brake application. So once we release pressure off our inlet port, pressure drops off, spring pressure pushes the diaphragm back up. When it does that, it uncovers the exhaust port. Any air pressure that's in the delivery port lines is exhausted out and our brakes are released. This way, this air pressure that's in the delivery lines does not have to go all the way back to the treadle valve to be released. We can release our front steer brakes really quickly. And that's the end of the first video on basic air brake systems.